Hey, welcome back everyone. This is Lin, and once again, I'm going to create this interesting educational video for all of you here on brilliant.org after another busy week now ongoing in December. So the weekend just give me like some time to refresh our mind and get prepared lots of things for the weekend. So like for this reason, I'm creating this educational video once again, brilliant.org. But however, today I'm going to introduce different chapter from this technology. Depending on your knowledge of how things work, this how technology works chapter is what I'm going to do some kind of work for today. So I'll click on it. Yes, how technology works. Understand the inner workings of everyday technology from online platforms to computer hardware. So currently in level 2 device and hardware, this chapter about wireless communication is something I'm going to cover is something interesting that you all discover and observe them later on. So I'll click start to begin. So you just wait for that content to get loading here. There we go. Sending a message. Every day we use devices that communicate wirelessly, filling the air around us with invisible messages. So every messages cannot be visibly seen. So like one transmission try to detect other things cannot be simply understood. So that's only a bit of a problem. Continue. Yes, this is made possible by encoding signals on electromagnetic waves. We see here this diagram with visible light, while X-rays, gamma rays have medical applications found the right. Wireless communication like radio waves and microwaves here. So increasing wavelength from this gamma ray to radio waves. So visible light is only around the center, so around average. That's a bit of a comparison. Continue. Which of the following devices does not communicate with electromagnetic waves? So we need to find the odd one out. Yes, a foghorn. Probably, yeah. Let's check. That's correct. So why for reasoning? Yeah, foghorns only emit sound, which isn't an electromagnetic wave. Only the other three devices also emit sound, also rely on radio waves or microwaves to send information. So this is the exception. Right, continue. Devices that need to send signals contain a transmitter that converts a small electric current into a wave. Note that receivers do something similar in reverse. Right, just for a bit of knowledge. Continue. The media sent by these devices could be as simple as a text message or as complex as an HD movie, but the principle of how the information is sent is the same. To send meaningful information, we need to transmit something that can change. When you talk, what can you change to transmit information? Loudness of your voice, pitch of your voice, very constant voice sounds, all of these. Probably this one, all of the above. Right, as long as something can be changed, information can be transferred as a result. The feat that wireless technologies accomplish is packing information into electromagnetic waves. Right, you know that already. Continue. The electromagnetic waves used by our devices often represented like this oscillation going like in frequent times from in according in x-axis, same amplitude, constant y-axis. That's what you're going to discover next. All right, continue. Let's see which of the waves seem like it's carrying a message. I assume it is both the top and bottom follows. Not quite. Top wave doesn't change at all, so gonna be carrying a message. Oh, so like kind of an assumption, like constant, constant amplitude could not carry a message. Like its amplitude stay the same. That's why. So an electromagnetic wave should be able to transfer a message in principle. Now let's see how it works in practice. Alright, this is called wave anatomy. We can encode information on a wave by varying its amplitude, represented by its height. This is how amplitude modulation radio works, better known as AM radio, like kind of in short brief form. Continue. Amplitude modulation powers some radio stations, but it's an outdated technology. Today, most wireless communication deals with digital data composed entirely of binary digits or bits, ones and zeros only. Ones, zeros, just alternating numbers. That's all. Continue. Right. Any piece of media can be encoded as a string of bits. For example, one encoding scheme A is represented by 8 bits. O, double one, four zeros, and 1. Which one do you think would need largest number of bits? 20 seconds music, 20-second video clip, text. Yeah, video clip with audio. This one probably. Right. A 20-word text message would need about 1,000 bits. 20 seconds of music about 2 million bits. Why? 20 seconds of movie will use around 30 million bits. Oh, kind of unpredictable statistical data is like kind of comparing, so that's interesting. Anyway, continue. We can transmit ones and zeros on a wave by switching between two amplitudes, one representing 0 and other representing 1. Toggle the buttons to change the wave. Let's say 1. You see, like kind of changing zeros and ones also change a respective amplitudes as required. If we all change to ones here, all will have the same amplitude at the same time. So constant shifting in amplitude y-axis along the constant x-axis. So this is brief observation. Continue. What binary signal could be encoded in this wave? Toggle the buttons to decode the signal. So only this is 0. Other 3 must be 1s. So this is it. Let's check. Yup, that's correct. Why for reasoning? Let's scroll down. The high amplitude here represents 1. Fourth section of this represents 1011. But you could use high amplitude for 0 instead. So 0100 also a valid solution. Doesn't matter which way around it is. 0100 also valid solution. Just varying amplitude, that should be constantly the same thing. So 2 alternative answers are possible here. Continue. Let's see it. Right here. This is one way you do transmit digital data or electromagnetic wave, and we could use this approach by any kind of media. Oh, LOL. Like transmit it, you see. The LOL will deliver to another message at the same time. Right, continue. Go scroll it down. However, if you listen to AM radio, you probably notice its poor quality. Well, this is because in practice, amplitude modulated signals get degraded by background noise, other source of waves distorting the signal. Too much distortion, interruption of electromagnetic waves that might frequently detect multiple changes whenever you tune in radio, shifting frequency signals and so on. Right, kind of observing what might occur, like kind of bit of detection and consequent analysis. Continue. Right. In conclusion, most modern applications change something other than amplitude in order to send information. So that's too much information we've read and previewed altogether. But we didn't attempt that many practice questions, but just basic information. You have to take care about the note and kind of discover more of these similar contents later on. All right, so lesson is completed, by the way. So I'll click this finish tab to conclude it. Wait. Complete. So in particular, only a few practice questions with gaining XP. So here 40 XP, very tiny proportion of experience points I've gained this time around. Continue. Wow. My total learning streak this week has extended to 2-day streak. Only returned on the previous day with some work on Friday and today Saturday, so 2 days in a row. That's it. Continue. It's better in the app. Over 95% of mobile learners prefer it. Okay, I just do not need to scan for downloading that QR code. No, not necessarily. Continue. Level up your learning with Premium. Okay, but I'm never doing Premium. After all, I'm just focusing on free account of Brilliant.org like this, so remind me later. Alright, how technology works. So overall, I've just completed that chapter of wireless communication, how frequency signals detection. We analyze how these binary digits and signals are related to each other by analyzing these binary data shifting value in terms of frequency and amplitude in varying amount of information. The following subsequent chapter is frequency and phase. That's kind of chapter I'm going to focus next time around. By the way, that's it for today's educational video that I've demonstrated. Thank you very much for watching, and if you do like this video, then don't forget to add a like and subscribe to my channel for other similar video as well. Hopefully, kind of this technology information is something quite relevant and helpful to your understanding. But I'll still come back to educational video to create more like these chapters in the future. Alright, that's it guys everyone. See you in the next video guys. Take care. Cheers. Bye.